Welcome to today's lesson on velocity time graphs. Our plan for this lesson is as follows. We'll start by learning about the key features of velocity time graphs. Then we'll discuss the significance of steeper and gentler gradients in understanding how quickly an object's velocity is changing. So far, we have delved into the concepts of displacement and distance and how they relate to motion. You have learned about how displacement is a vector quantity that considers direction, while distance is a scalar quantity that only considers magnitude. We have also discussed the basics of interpreting displacement time and distance time graphs. Building on this foundation, we can now introduce velocity time graphs. This lesson advances our understanding by exploring how velocity changes over time, helping us gain deeper insights into the motion of objects. The first feature we'll look at is axes. The horizontal axis, known as the x-axis, represents time, typically measured in seconds. This means as you move from left to right on the graph, you're looking at how the object's motion progresses over time. The vertical axis, or the y-axis, represents velocity, usually in meters per second. Positive values on this axis indicate movement in one direction, while negative values indicate movement in the opposite direction. Next, we'll explore the gradient and its meaning. The gradient, or slope of a line on a velocity time graph, is a crucial feature. It shows the change in velocity over the change in time. This represents acceleration. A steeper gradient indicates a greater rate of change in velocity, which means higher acceleration. Let's look at some example cases. If an object is moving at a constant velocity, this is shown as a horizontal line on the velocity time graph because the velocity remains unchanged over time. For example, if you see a horizontal line at 5 meters per second, this tells you the object is moving at 5 meters per second consistently. When an object is not moving, its velocity is 0. On the graph, this is represented by a horizontal line along the time axis. If an object is speeding up, its velocity increases over time, so this will show on the graph as a line sloping upwards. The steeper the slope, the faster the object is accelerating. For instance, if the line rises from 0 to 10 meters per second over a span of 5 seconds, the object is speeding up. Conversely, if the velocity decreases over time, the line will slope downwards. The steeper the downward slope, the faster the object is decelerating. For example, if the velocity drops from 10 meters per second to 0 meters per second over 3 seconds, the object is slowing down rapidly. If the slope of the line, whether upward or downward, is gentle, it implies a gradual change in velocity. A gentle upward slope means slow acceleration, and a gentle downward slope means slow deceleration. In today's lesson, we delved into the main features of velocity time graphs and their importance in understanding motion. We started by clarifying the axes. The horizontal axis represents time in seconds, and the vertical axis represents velocity in meters per second. We then learnt that the gradient of a line on these graphs denotes acceleration, with steeper gradients indicating higher acceleration and gentler gradients showing slower rates of change in velocity. Finally, we examined various cases, including constant velocity, zero velocity, speeding up, and slowing down, along with how the slope's steepness impacts interpretation. Watch the rest of the GCSE physics course at Sophos Education.